Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about enumerators, how to implement IEnumerable and IEnumerator. Okay, so something we've already seen several times is doing a simple for each on a list. So we can do a list of int, some kind of int list. Then we just construct a list and we can do a for each int I in the int list. And yep, this works perfectly. So we can do a for each and cycle through every element in our list. But then if we try doing a for each on some kind of custom type, so for example here, let's make a player, new player, and then let's try doing a for each on this player, and nope, this does not work, we have an error. Like it says here, the for each statement cannot operate on variables of this type because player does not contain an extension definition for getEnumerator. In order to make the for each work with custom types, for that we need to make our custom types enumerable, so let's learn how to do that. For example, let's define a class for holding a single stat, so some kind of name and value. So just name it stat, and inside just have a string name and just an int for the value. And then let's make a class to hold a bunch of player stats. So class called player stats. And over here, for example, let's have some fields of type stat. Let's say for dex, for strength, wisdom, and so on. So yep, just like this, let's just construct these objects. Okay, so yep, just like this. And now let's say that we want to do a for each, and we want the for each to work on our player stats. So basically we want to be able to cycle through each one of these stats individually. So to do that, the first thing we need to do is over here, let's implement an interface. Let's implement the IEnumerable. This one takes in a generic. So let's say our generic type is going to be of type stat. Yep, just like this. So now we can implement this interface. So it requires us to implement those two functions. This requires us to do something that constructs an object of type IEnumerator. So enumerable and enumerator, those sound similar, but they are different. So let's make a class that is going to be our enumerator. Usually for that, we build it as a nested class. So up here, let's make that. So the player stat enumerator, and we're going to implement IEnumerator, and again, also of type stat. Then let's see what we need to implement on this one. So over here, let's select, and then over here on this little light bulb, let's implement this interface. So yep, there you go. Now we need to implement all of these. And over here, we just need to handle some kind of index. And based on the index, we're going to return either of these ones. So that means we also need a reference to our player stats object. So let's make a constructor here. And on the constructor, let's receive our player stats. So you have this, let's store it inside. So just like this, we have our player stats. And then we also need some kind of index in order to know the move next, the current, and so on. So let's do an int for the index. And for the index, let's default it to -1. The reason for that is because the for each is going to call the move next before it grabs the current. So let's start off at -1. And then on the move next, that's pretty simple. So let's just do index ++. Then since we have just 3 stats, so this one is going to be index 0, 1, and 2. Because that over here, if the index is bigger than 2, if so, let's just loop back to -1. Then this one needs to return true if the enumerator was successfully advanced, and false if it has passed the end of the collection. So we can just return if the index is not -1. Okay, that's our move next function. To dispose, we don't really need to implement that one. And the reset, we can just set the index to -1. So what's important is over here the current. This one is a property, so let's go ahead and implement this property. This one is going to have a get, and on the get, we're simply going to test out our index. So let's do a switch on our index. Let's add a default, and let's add a k0. So k0, let's return, go inside the player stats. And on index 0, let's return, for example, let's go up here, let's see, so the first one is dex. Then k's 1 and 2. For this one, let's return strength, and this one, let's return wisdom. Okay, so yep, so that's the current, and over here for this other current, we can just do a pass-through onto that one, just like this. So yep, this is our enumerator class. So we receive our player stats, so we have the original object, we have some kind of index, then on move next, we just increase the index, and on current, we just grab the value based on that index. So now here on the get enumerator, we only just need to return a new player stats enumerator object, and on that one we need to pass in this. So just like this, and on this one again, same thing, we can do a pass-through function. So return get enumerator. Okay, so now finally up here we can let's construct an object of this type of our player stats. Let's construct a brand new object. And now, yep, now we can do a for each on that one. This one is going to return a type stat in our player stats, and let's just do console.writeLine on our stat. And just to be able to see that, let's go inside our stat. So inside this one, and let's just override our toString, and let's return the name and then the value. Okay, so just like this, let's test and see if our for each is working and if it's going to go through all of our various stats. And if there is exactly like that, so it did a for each through our custom type, it found dexterity, strength, and wisdom. Alright, awesome. So this is how you make your custom types work with a for each. You just need to implement both of these interfaces. Just do that, do some basic logic in order to grab the current value, and with that you can then use your custom types inside a for each. By the way, alternatively, for this specific use case, where we have a fixed number of elements that we want to cycle through, for this a simpler approach is just on the enumerator. We can just do a yield return. So over here on the function to get the enumerator, instead of creating a brand new enumerator, instead of defining this entire class and creating all of that, if we just have a fixed number of elements, we can type in the keyword yield, yield return, and then whatever we're going to return. So let's say return text, then do another yield return for strength, and another one for wisdom. Basically, what this is going to do is this function is actually going to be called multiple times. So by making something IEnumerator and using yield return, by doing that, this function is essentially going to store its state. So the first time that we call this, it is going to return dex. The second time we call it, it is going to return strength. And the third time we call this, it is going to return wisdom. Let's test this. And if it works exactly the same, we have our 3 stats. So basically, whenever you have a dynamic number of elements, so if inside your custom type you have some kind of list, some kind of collection, for that you can define an entire enumerator and write all of this code. But when you have just a fixed number, just a bunch of simple stats, a bunch of simple elements, for that, just using a simple yield return, this one is much easier. Also, since we're on the topic of IEnumerator and IEnumerable, let me mention one Unity-specific thing, which are coroutines. If you're just using C# without Unity, then don't worry about this part. But Unity basically has coroutines, which is a way to run logic across multiple frames, and specifically it works with IEnumerator. In order to make a coroutine, we make a function that returns IEnumerator, and then over here you can do whatever logic you want. Then when you want to split the logic, you can do yield return, and then Unity actually has some nice built-in functions. Like for example, we can do yield return, wait for end of frame. This is basically going to wait for the end of frame before running the code down here. Or for example, we have wait for seconds. This is going to wait for a bunch of seconds before continuing to execute the code. For example, let's wait for 3 seconds. Then let's do a debug.log and say something. So let's do debug.log before and after. Okay, so this is going to basically run some code after some time. So this is a great way to handle timing-based logic in your games. With this, we have a coroutine. And now to start, we just need to be working inside a MonoBehavior class. And of course, this script needs to be attached to a game object. So then we do this, and let's make a start. And over here on start, we just need to call the function start coroutine. And this one takes our IEnumerator, so let's just call my coroutine, just like this. Yep, so this is going to start running this coroutine, so we should be able to see this log immediately, then wait 3 seconds and then see this log. Okay, it's running, there's the first message, and after 3 seconds, we should be able to see, yep, there it is, the second message. Alright, awesome. So these are coroutines, which is a Unity-specific thing that works with IEnumerator. Now personally, I must say I'm not a big fan of coroutines, simply because I don't like this pattern that they force you to use. It feels needlessly convoluted to me. You need to be working on a MonoBehavior, you need to call start coroutine, you need to make a special function that returns IEnumerator, use yield return, and so on. So personally, I'm not a big fan of this huge pattern. Personally, I prefer using super simple float timers, but coroutines work great, so if you like this, then definitely go ahead and use them. Okay, so those are enumerators. It's how you can make your custom types work inside a for each and various other settling logic. For example, things like link, which we're going to cover later on in the advanced section.